Hey, Mitch, could you turn it down just a little bit? Just a little bit. Okay, so I'm going to get started. We don't have any attendees yet, but I'm thinking that probably this is an odd time. We haven't done this on a Wednesday night, I think, at all this semester, so I'm not that surprised that I don't have any attendees yet. But I'm going to go ahead. I'm going to start with discussing what we're going to do this week. I want to have 3 of these online sessions or recorded sessions. The first of which tonight, I want to go over the community health survey for 2 reasons. I want to just demonstrate it to you, show you that this valuable resource about community health issues in New York City is available. And number 2, it's a rich source of data for some practice for us, in applying some of the statistical tests that we've learned. So for tonight, I'd like to introduce that data set, show you where it came from, download it, talk about coding in SPSS. And then I want to actually apply it, take some variables in that data set and do some descriptive statistics, find means, find the percentages of values in categorical variables, perhaps produce a few bar graphs, produce a few histograms, box plots, and so on. So I think that's a good combination lesson that might be interesting as a review for stuff we've learned this semester to kind of cement it in. One of the most discouraging parts about teaching this particular course is that a lot of times, and this is human nature, a lot of times people tell me that they'll take the course and then 3 months later, if they haven't practiced it or used it, they've forgotten most of the material that they learned during the course. So I'm hoping that you guys will have reason to use this stuff and maybe even on your own, go back and take a look at, use SPSS or practice with it or Excel and go back and take a look at this community health survey and get an idea of what you can do with it and what the use of statistics when applied to these questions and variables that take place in this survey are. So first thing I'm going to do is I'm going to go to the website on Blackboard. I'm going to go to the weekly session here, weekly sessions, and go to session 14. Okay, and one of the principles for collecting this data and encoding it and so on and so forth was nice enough to stop by and address one of the other classes, and we managed to get that recorded so you can see her introduction to the community health survey right here. If you click on that, it'll take you over to that presentation. I hope you get a chance to take a look at it. It's really interesting. Okay, so actually up here. So if you get a chance to take a look at it, I don't think these are clickable, but the ones that's the same group of tools are down here, so you can click on them. So I'm going to go directly to the main site for the New York City Community Health Survey. In fact, if you take a look at that, you can actually see the site. You can actually navigate to it, or you can Google to it as by New York City Community Health Survey. It'll probably bring you right here as well. So I'm going to take a look at this. There's various areas that you might work in here, particularly in the data area. Okay, we have several areas that we might be interested in. One is an area where tools and maps are collected. Okay, and there's various tools. One's called Epicury, one's called an environmental health data portal, so on and so forth. You might want to take a look at some of that. I'm going to demonstrate Epicury in a second. The actual data sets, a little bit of duplication here as well. The actual data sets are also listed here. There's a duplicate here. Environmental health, Epiquery, that brings you back to the same spot, and the community health survey itself. I'm going to start with Epiquery. Okay, that's an interactive data tool that allows you to look at different periods in New York City when they collected community health surveys. Generally, they surveyed, I believe, something like 8,000 people every year. Some of them are people that they went back to and ask the same question each year to see if there were changes in health status, in their behavior, so on and so forth. Okay, but most of them were randomly selected individuals throughout the population. Okay, so and it's broken up into different groups here. I'm going to start with this brings us to the data that's stored here for 2002 to 2014. 2014 is the most recent one that they've actually accumulated the data for. Okay, and they were asked in these surveys, the subjects were asked many questions, such as, have you ever been diagnosed with diabetes? So I'm going to click on that one right there. Do you have a history of depression? They actually asked phrase that question a little bit differently than the way I've just phrased it. But basically, it's a question that's geared to determine whether there's a history of depression. They have self-reported health status, fair, poor, good, and so on and so forth. Whether or not a person's been vaccinated, whether they've been vaccinated, whether or not they're smokers, how much they smoke, where they buy their cigarettes, whether or not they drink alcohol, whether or not they've ever been diagnosed with asthma or currently suffering from asthma, and so on. So I'm going to click into one of these things, which is diabetes. I'm going to go down here. Well, the first thing I see is that select one, age adjusted or unadjusted. Well, when they do the survey, right, they may find that the 8,000 people that they wind up with in the survey, for whatever reason, the methodology, perhaps these are all done by phone, and so the people that have phones are represented more than people that don't have phones, maybe a younger population, and so on. So the data has been available. They've made the data available so you can work with it as age adjusted or unadjusted, literally the crude percentages. So if I have unadjusted clicked, it's going to give me the actual percentages that they found that of the 8,000 people that reported diabetes, that they've been either ever been diagnosed as having diabetes in that survey for 2014, those 8,000 people or so. So I'm going to click on that. I'm going to say, okay, let's submit that and see what we come up with. Okay, these are the crude numbers. So notice that this is now adjusted for the true population of New York City. The percentages are the crude percentages, just as you would expect, but it's adjusted in terms of like the number of adults. That's an estimate of the actual number of adults based on the percentages in the survey. Okay, so 10.5% of the people that was surveyed reported that they had been diagnosed with diabetes, and they've actually given us a confidence interval here. And we know about confidence intervals with proportions that actually we're 95% certain that the true proportion of New Yorkers that have been diagnosed with diabetes based on the sample size is 9.7 to 11.4. The point estimate is 10.5, which would represent about 676,000 adults. We have a bar graph that they give us as categorical variables, yes or no. So it produces a bar graph, and we can see relative percentages graphically displayed of whether someone has been diagnosed with diabetes or not diagnosed with diabetes. So this is a descriptive statistic, the kind of descriptive statistic that would be associated with a categorical variable. In other words, diabetes, diagnosed, yes or no. That's our category. So now we can actually break this down and refine this, factoring it into additional variables. So, for instance, here we can tell that we'd like to see, give us this data again, except give it to us broken down by gender, by age group, by marital status, by borough. Let's try something interesting. How about education level? Let's see how education level might impact the rate of diabetes. So now it's going to do the same display of data, except now it's going to take this categorical variable and factor it into groups by education. So I'm going to hit submit. Again, I'm working with the crude estimates on age adjusted. And let's take a look, see if we see something interesting here. We'll take a look at this. The rate of diabetes among the surveyed people that were less than high school graduates was 18, almost 20% within that population. Among high school students, was high school graduates 11, some college and college graduates. We can see a progression here, lower and lower. So in other words, education appears to be a protective influence for diabetes. Of course, there may be other factors that are hidden here. So, for instance, college graduates make more money, so it could be, instead of what we may be seeing here, is perhaps something that's associated with poverty level rather than specifically with education. Well, in fact, let's go back here. Let's take a look at this not just by education, but by within education by, let's see, household poverty rate. So we can actually break this down into finer groups as well. And here we go. So we can actually, if we really wanted to take a look at this, we could see this based on, let's see, less than high school, based on the poverty. We can compare less than high school with a lower percentage of poverty versus college with roughly the same percentage rate of poverty. So we can get a little bit better look to see if we can distinguish whether poverty is the issue or education is the issue, or perhaps both are influencing this. So this is an interesting tool. You have many variables that you can examine here. Now, the only downside of this is that you're not actually working directly with the raw data. You're working with a tool, this EpiQuery tool, that allows you to examine and work with this data. In addition to this, let me go back again. In addition to this, we also have another tool here. We have the Community Health Survey itself, the actual raw data. So if I go down here and we look into public use data within the Community Health Survey, in other words, this actually published so that we can actually see this. Now, there's no individuals identified. There's no, so they don't have to deal with privacy issues and so on. They make sure that the people who took part in the survey, their identities are well hidden. So if I scroll down here, we can go into the Community Health Survey public use data sets. We can go into that and look at it for the actual raw results for 2014, 2013, in this case, all the way back to 2002, the group that we were just looking at. Okay, so I'm going to go in here and I'm going to take a look at what does this questionnaire look like that these people answer. Okay, if I go into this PDF file, I can actually see the groupings of the questions: health status, access to health care, cardiovascular health, diabetes and asthma. If I go down to diabetes and asthma, the question group 4, the first question they ask: have you ever been told by a doctor, nurse, or other healthcare professional that you have diabetes? Okay, and if it's yes, and female, was this only while you were pregnant, so they can get a little bit more information. So the answers are yes, yes, only during pregnancy, no, didn't know, not sure, or refused. Well, we got more than two categories there. Yes, it wasn't just yes and no, right? It's a little bit more complicated than that. But we know how to deal with that. Let's take a look at how to deal with that when we get into SPSS. Okay, so how about asthma status? Have you ever been told by a doctor, nurse, or other healthcare professional you had asthma? So the answers there are yes and no, don't know, not sure, or refuse. Basically, these are don't know, or refuse are missing values, right? They didn't answer, basically didn't really answer the question. So here we really only have two available values for this particular question. Okay, yes or no, and so on. So, and we have another one here. Have you had an episode of asthma or asthma attack in the last 12 months? So we have some more information, and we have many other questions. One of the things that I find interesting is that they get 8,000 people that are willing to sit still long enough to answer all these questions. I'm not sure what they do to induce them to do this or to take part in this, but apparently they don't have a problem finding subjects for this. So at any rate, so this document represents the actual questions themselves that the surveyor would use to ask the subjects. Where were you born? Please tell me the country, for instance, USA or not USA. This question 8.6 is asking about nativity. Were you born in the United States? Yes or no. right? Yes, in the United States, no, not outside of the United States. Okay, and if they answer that, no, where were you born? They then can the surveyor can then put a double-digit number down to indicate where they were born and so on. So many questions here. So let's go back to where we were. Here's the questionnaire, right? Let's go back here again, and we have the actual data set itself. Okay, so for instance, one of the things we have here is that we have the data set and we have a code book. The code book is a summary of how the data is coded or input into the computer. Okay, so I'm going to first download the data set. So if I click on that, it will actually save this binary file, Community Health Survey 2014, public.sas7.bdat. This is actually an SAS file, a different program that we use. However, this data can be imported into SPSS, and I've already done that for us. You've probably noticed it in your project folders and maybe some other places. So I've already downloaded that. We don't need to do that now. The other thing that's of interest here is also the code book. Okay, and the code book, again, is a summary of what these various different values were. For instance, this time I'll go to health status. Okay, so general health status, that's the name of the variable. When we look into SPSS, that variable will be named general health. That word represents the variable. The question is in the label. Okay, would you say generally health is excellent, very good, etc. Okay, and the raw name actually might be health 1. We'll actually see that in SPSS when we take a look at it. That's the source, the question number. And the available answers are 1, 2, 3, 4, 5, excellent to poor. Okay, and the others were non-answers, don't know, or refused, and so on. And this was asked in every year from 2002 to 2013. And apparently wasn't, I'm not sure, prior years, yeah. It was asked this year too, obviously, since it's in the code book for this year. But it was asked every year previous to that, going back to 2002. So let's take a look at the actual data itself that I've already downloaded for us. Okay, I don't want to close this yet, but I do want to get to my folder here. Okay, so let's take a look at what I have here. Right now, I'm looking at the data for the year 2013 rather than 2014. You guys could download 2014 and import it into SPSS if you wanted to. So 2013, I'm going to import this into SPSS. One way is I could double click this and it will open SPSS. Since it's an SPSS data file, I already imported it and saved it as a SPS data file, .sav file. The other thing I can do with this is I can just go to SPSS and say open data, data, okay, and then I can navigate to that document. I know it's on my desktop, so I'll go to my desktop. Okay, and I know it's an SAV file. Okay, and I know it's also in New York City Community Health Survey 2013. And here are two files. One of them is the full data set. The other one we're going to get to in a second. So I'm going to click on that one and say open. And SPSS will open that data file. And here we see that here's the various values that we have for these different variables that are present in this survey. In other words, mood represented mental health status, and each one of these, mood 4 represented a question answer to a question. It looks like, for instance, that in most of these, the answers were somewhere 1 to a 5. A demographic, we'll take a look at what that represents. Perhaps that's the age or something like that. Nationality, nutrition was a short answer for another question. So the variable names, remember, they have rules in SPSS. They can't have any spaces. They got to start with a letter, and they can only be letters and numbers. So they're not very informative. But the way we're going to find out about them is by looking at the code book to see what those variables actually represent. So I'm going to go here to View, and I'm going to click on it on Value Labels. And notice that they don't change. And the reason why they don't change, in other words, the ones and so on, 1s and 5s don't go away when I do this and actually show the values, because this data hasn't been coded. So I'm going to go into the variable view, and I'm going to see, well, this variable is called mood1. Okay, and I'm gonna actually look down here and see if there's a couple of interesting ones. Ever asthma, that one sounds familiar, right? We're just talking about that. I'm actually gonna see if I can't drag that up to the top. Gonna click here on the end. Whoops, that's not what I wanted to do. I gotta select it alone. Ever asthma. Okay, I'm gonna drag that all the way up to the top. So that's in the first column now. And the question, remember, we wanted to know what the question was. Okay, ever been told by a doctor, nurse, healthcare professional that you have asthma? Okay, so that's one of the variables that I might want to work with right now. And demographic, well, what is that question? What is that question about? Okay, let's spread this out a little bit. Okay, demographic one, what is your age? That's an interesting one. That happens to be, notice, a scalar variable, numerical variable. Let's move age up here as well. Okay, and let me see if I can't find something else interesting here that we might want to work with. Okay, how about smokers? Okay, type of smoker, heavy smoker, the smoking status. That's probably, are you a smoker or are you not a smoker? So let's move that up there too, because that might be interesting, right? Whether or not smoking status has something to do with asthma, for instance. Whoops. Whoops, let me grab it again. Okay, age, there we go. Okay, good. So right now, demog one, which is just age, basically age. I'm going to change that to age of subject. Make it a little easier to understand. Okay, and I'm going to change this one to asthma, just whether you've ever been diagnosed with it or not. And smoking status, pretty descriptive. I'll leave that alone. Now, I need to tell it a scalar variable like age. Well, that's already something that's a number, right? That's the number of years that they've been alive. Smoking status and asthma, however, are categorical variables, right? So those categorical variables, I need to let SPSS know what the various values in there represent. Okay, and where am I going to find that information? What a 1 or a 2 represents when it's coded in here. Matter of fact, let me take a look. See that ever asthma, those mostly look like 1s and 2s. Demog 1, which is actually the age of the subject, those actually have a person's age there. Pretty old group up here at the top, right? But we can see it's distributed otherwise. Actually, we'll take a look at how it's distributed because we can do that as part of our descriptive statistics momentarily. And smoker, so we have a few categories there, 1, 2, 3, and so on and so forth. So let's go take a look at our codebook. Okay, I'll get this out of the way. And let me open up my codebook for 2013. And the first variable that I'm interested in is ever asthma. Okay, so I know I can probably go through here and find it. Oh, maybe I'll get lucky. Here I got lucky. Ever asthma. 1 means yes, 2 means no. And the others, I'm not going to bother to code because they're just missing answers, basically. 1 yes and 2 no. Okay, let's see. Ever asthma. Variable view. And so if I code this, 1 represents yes, and 2 represents no, never been diagnosed with asthma. Okay, so I'm going to do the same thing for smoking status or smoker. Let's see what those numbers represent as well. So instead of going all the way back up to the top, I'm just going to put in, I guess the variable name was smoker, and it's going to put in smoker here. See if I get lucky and manage to find it. But there's, it was found on 7 pages. Well, look, we got lucky. We found it again. Okay, have you smoked at least 100 cigarettes in your entire life? So that's their definition of whether you're a smoker or not. But they say, let's see, 1 is never, 2 is current smoker, and 3 is a former smoker. Okay, so we have 3 categories there, not 2. Right? So 1 is never, 2 is current, and 3 is former. Okay, let's go back and fill in those descriptions. Okay, I'm simplifying this because I really want to get through this. One is never smoked. Two is current smoker, I think. And with nobody here to correct me if I'm wrong. Very disappointing. Current smoker. And three is a former. I'll go back and take a quick look just to make sure. Okay. So now I've coded these variables. Let's just want to make sure. Yeah, I got that right. Okay. So now I've coded these variables. So now when I go back to my data view, I can actually see what the values are. Right? Former, this is a person who was 64 years old, has been diagnosed with asthma at some point, and is a former smoker. Subject number two was never diagnosed with asthma, never smoked, and is 28 years old. Okay, so we can do some interesting stuff even at this stage. So let's think about descriptive statistics. One of the things, for instance, if we're going to do some work with these statistics, we might want to understand something about the population of New York City, the nature of the people in the population in New York City. For instance, we might want to know what percentage of them are female and male, okay? Or we might want to know, matter of fact, let's add that variable, as a matter of fact, right now. So let me see if I can't find gender in here. Okay, and I don't see it. Didn't come up, okay. How about sex? Sex is going to come up on a lot of this stuff. Sexual behavior, health status, mental health, demographics, probably in here somewhere, right? 21 and up. Sex, sometimes difficult to determine over the phone and asked to confirm with everyone, are you male or female? Okay, there you go. Okay, so if I look for the variable sex, one is male and two is female. So I'm going to add that to our little search here. See if I can't find it quickly. Here we go. Here's sex. I'm going to again move this so that it's up here, so it's convenient for me to work with it. Okay, I'll put it right at the top here. Whoops. Oh no, I lost it. Let's try that again. I got too ambitious. Okay, let's put it in there for a second. Okay, I'll tell you what. Let's move sex and age up to the top. I move ever asthma down below the two of those. Oops, made one step. Okay, sex, age, ever been diagnosed with asthma, and what was that again? One is male. Okay, so let's go into the values here. One is male, and two is female. Okay, so let's say we're going to do a study on whether or not people, based on their availability of insurance, are likely to be vaccinated for the flu. Okay, and whether they were more likely to be get a flu inoculation if they were insured versus if they didn't have insurance. Maybe we might be interested in that. None of those variables are here that we've coded yet. They're buried in here. They are here, whether or not someone got a flu vaccine that year, or whether or not they're insured, or what kind of insurance they have, health insurance they have. That's here. But in the variables we've looked at so far, we have information about the nature of this population. So if you're going to go ahead and evaluate this population with regard to that, maybe we want to know some more. Maybe we want a description or descriptive statistics for this population. So how might I go about that? Well, let's see. Let's start with gender. Okay, I'm going to go back here to the data view, and we can actually see this a little bit more clearly now that it's coded. Remember, I can go to View, take away the value labels, and View, show the value labels right here. So let's say I want to, as part of my presentation or my study, mention that, gee, is this a population that has a lot of females in it? Is it an older population, younger population, and so on? So let's take a look at what the distribution of males and females is. So it's a categorical variable. So I'm going to go to Analyze. I'm going to go to Descriptive Statistics. Since it's a categorical variable, I'm going to go to Frequencies. Okay, so here we go. So I'm going to take gender or sex, move it into variables. I'm going to ask it to, let's see, I'm not going to do these calculations, these statistics, because they're really intended for numerical variables. Quartiles, mean, median, mode, that really isn't applied to gender, right? But we certainly can get a chart if we're interested in. And the type of chart we're probably going to want is a bar chart, perhaps a pie chart, but not a histogram, right? Histograms are the domain of numerical variables. So we're looking for a bar chart, 1 bar for male, 1 bar for female, right? Because that happens to be the 2 values that we have. Okay, I can do it by frequencies, the number of males and females, or I can do it by the percentages of males and females. So I'm going to click OK. I'm going to ask SPSS to go ahead and do that for me. So it's going to display the numbers, the actual numbers of males and females in a box, because this is checked as well. So let's click OK and see what we wind up with. Well, here we go. There are, in this survey, there were 8,698 people that reported whether or not they were male or female. There were 3,700 of them were male, 4,900 of them were female. So more females answered this survey, and if it's indeed a random sample, that would suggest there's more females in the population. Okay, but certainly more females answered this survey than males did. And here's a bar graph that actually demonstrates the relative difference between the numbers of males and females in this population. So this, in a sense, is a descriptive statistic. I'm going to repeat that. This time I'm going to do it for another descriptive statistic. Let's go to frequencies again. Except this time, let's do it for smoking status. How many people are smokers? As a matter of fact, let's do it for asthma, and let's do it for smoking status. Let's do it for all 3 at the same time. I'm going to click this, and sure enough, here we have a table for the number of males or females, a table for the number of people that reported that they had asthma. Oh, did I misspell that? I guess I must have. Versus didn't have were never diagnosed with asthma. And smoking status a bit more, right? Never smoked, 63%. Current smoker, 14%, and former smokers, 22%. Right? That means that 37% of the population at one time or another was a smoker. Okay, so let's take a look. Here's the bar graph for gender. Here's the bar graph for asthma, percentage of people that have been diagnosed based on this survey. And here's the smoking status. So we have a large number of people that had never smoked, but we have more former smokers now in this year than we have current smokers. Okay, so that's interesting. We've learned something about this population. That's what descriptive statistics is all about, learning some facts about the population. Now, kind of descriptive statistics that we would employ to understand numerical variables, like a person's age, a person's blood pressure, and so on and so forth, or population's age and blood pressure, is going to be a type of statistics that would give us a point value like a mean. So let's go into descriptive statistics and go into descriptives. And let's take a look at the age of the subjects in this study. Okay, so I'm going to go into options, and look, it's going to find these various values for us: the mean, the variance, the standard deviation, and so on and so forth. So I'm going to click OK and see what I wind up getting. Okay, and if I go down to the bottom here, my minimum, my youngest person, remember this study only involved people that were 18 years or older. Minimum age was 18 years. Maximum age was someone who was 97 sat through this interview and answered all the question. The average age of the people in this survey is 49. Now, we didn't get a median from this, so we have a limited number of about information. We see the variability here as well. So I'm going to go back here to Analyze, to Descriptive Statistics, to explore because I know Explore is going to give me more options. I'm going to move the age of the subjects in here, and I'm going to go here and I'm going to say, oh, look, confidence interval. It'll actually calculate a confidence interval for the true outliers. Excuse me, a confidence interval for the true mean age for this population. Before, we just got the mean age of the people that were surveyed. Now, we're going to get the mean age of people that were surveyed. We're also going to get a confidence interval for the true mean of the entire population. Now I'm going to click percentiles too, see if that helps me out a little bit. Now plots. I'm going to ask it to produce a histogram for me. It's automatically going to produce, when I use Explore, a box plot. I don't have to tell it to do that. Stem and leaf plot, we've looked at those, kind of archaic, right? So I'm not going to bother with that. I'm going to click OK. Notice it's going to do both, display both the statistics and the plots. If I only wanted one, I would just check off one of those instead. Let's see what I get. So the mean value for age is as it was before, same thing, same calculation, 49. The 95% confidence interval for the true mean of the population is 48.8 to 49.6, and so on and so forth. The variance, the standard deviation, the range is 79 years, 97 minus 18, and we can see how that's figured out. The interquartile range, I got percentiles, 5% of the respondents were 22 years, were under 22 years. 26% of respondents were under 26 years. 50%, that's my median. My median was 49 years old, very close to my mean. Let's take a look at the actual distribution of ages. Okay, and you kind of think it kind of looks a bit skewed, but remember, we purposely eliminated people that were under 18 years. We didn't interview people for privacy reasons that were under 18 years old. So we actually might have had a kind of an interesting looking normal distribution here, right? In this case, it's skewed to the older ages, right? The true average mean population is less than 49. Why do I know that? Because it's skewed to the right, so the average is pulled away from the true mean, And the reason why it's skewed to the right partly is because we didn't include people that were under 18. So we know that the mean of this group is 49 and the median is pretty close. But that's without counting people under 18. Right? So it's pretty interesting. And here's a box plot. Here's our box plot that shows us our minimum age was 18, our maximum age, which was 97, our median, which is roughly 49 if you go over here, and our interquartile range, which, if you look back at this box, 25th percentile and 75th percentile, that'll give you the level for here and the level for here. Okay, the top of this box and the bottom of this shaded box. Okay, so again, this is very interesting material. I can display with a graph what this information looks like, what the distribution of ages in this sample, perhaps even representing this population, how they're distributed, where the interquartile range is. And I can see it's skewed here because the median is not in the middle here, is it? There are values that are way up here, right? And so it's not as far from the median to the lowest values as if from the median to the highest values. So we can see that there's a skew here to the right, right? And we can even detect that in the box plot. It's a little bit of a cheat skew because it's only because we didn't sample people that were younger than that. So now, one of the things that you can do here is that it's very nice that we were able to do this. I'm going to close that. Very nice that we were able to do this for individual variables, but you can also do this for combinations of these. In other words, what was the average age of smokers versus non-smokers versus people that never smoked? Let's take a look at that. Let's analyze descriptive statistics. Remember, it's a categorical variable. Did you smoke? Right? And there are three possible values. And there's a numerical variable, age. So I'm going to find the mean ages of smokers versus non-smokers versus people that never smoked. Okay, former smokers rather. and people that never smoke. So I'm going to go to Descriptive Statistics. To be able to factor that mean into different groups, I need to go to Explore. So if I go to Explore, age of the subject's already in there. Now I'm going to factor that, not by sex. I could do it by sex to see if the average age for females is older than males. But I'm going to do it by smoking status for our purposes. Okay, so I'm going to put that in there, and I'm going to say okay. Okay, I think I can say okay, yes. And it will indeed find the average age of people who never smoked was 47. People that are current smokers are a bit younger. I guess maybe people that get older, maybe they have health issues. They have to stop smoking, right? How about former smokers? Well, the older group is the one that's the highest age, average age for average age for former smokers is 57. And I'm willing to bet, with a couple of reasons for that, they've been around longer, so they have more of a chance to have sometime during their lifetime have smoked. But also, I'm thinking that a lot of former smokers are older people that have given up smoking because they're dealing with health consequences of it at that stage. Okay, so that's pretty interesting that we have that we're able to see this difference in these rates of smoking, whether or not it's former smoke, the average ages, people, whether they're smokers or not smokers. And you actually can see that here. Here's the median for former smokers. Here's the median for never smoked, and current smokers roughly about the same age. But former smokers tend to be an older group, and I'm thinking maybe that's the case there too. So there's a lot of things we can do with descriptive statistics. Now, I'm just going to tip off tomorrow night, Thursday night, when we're at 125th Street. I'm going to pick up with some of these data sets, and we're going to discuss analysis of variance and correlation and regression. Those are the last topics that we've had since exam 2. Those are the main topics we've had since exam 2. Okay, and so those are going to be questions on the final exam. Now, just for you guys that have issues with SPSS, I'm considering just producing the tables in SPSS and having you interpret the tables so that it doesn't ridiculously disadvantage people that either can't afford to buy SPSS or that had an issue with it crashing, which some of you have had, or that were using it on virtual desktop and are having miserable time trying to get virtual desktop to work reliably, as I know some of you have as well. So I'm hoping to get around the issue of shutting people out or disadvantaging people because of these issues with SPSS that maybe as we go into next semester we'll be able to resolve and not have to worry about that quite as much. Okay, so if I wanted to compare, if my null hypothesis was, for instance, was that there's no difference between the mean age for people in this population that never smoked, the mean age for people who are current smokers, and the mean age for people who for former smokers. If I wanted to compare that, create a hypothesis for that, I would say the mean 1, never smoked, is equal to mean 2, current smokers, equal to mean 3, former smoker. 3 categories, right? 3 possible values in that categorical variable. Okay, so 3 means. I want to compare 3 means. So if we're with 2 means, in other words, males versus females smoking, right? Ages, the age of males versus females, I would use a t-test, which we used earlier in the semester. If in this case, I want to compare 3 means, I have to use analysis of variance. So Thursday, we're going to be looking at analysis of variance and correlation and regression. And the reason why I want to make sure we go over that on Thursday is because I'm going to make the test available before that class, but I'm hoping many of you will probably wait until you see that before you start working on the exam, so you can take advantage of the fact that I'm reviewing exactly material that's going to wind up on the exam, so you don't get disadvantaged by having skipped that. Okay, so let me just do that quickly now since I have this up. I'm going to go to, okay, let's see, analyze, compare means. Now, but if this were one sample, and you know, an average age versus a certain number, I would use that. Independent samples, 2 groups, male or female, I would use that. Asthma, yes or no? What's the average age of people that reported having diagnosed with asthma, yes or no? Or diabetes, for instance. But this one is going to be analysis of variance because I'm going to compare 3 means. So I'm going to click on that and I'm going to say, well, gee, the age of the subject is what my average is. And I'm going to say that I'm interested in knowing whether or not the average age varies by smoking status. Is mu for non-smokers equal to the mean age mu for smokers equal to the mean age mu for former smokers. Okay, I'm going to move that into the factors list. So I'm going to click OK. And SPSS is going to do our analysis. Excuse me. I'm going to pull this up to the top. And here it is. Sum of squares between the 3 groups is that number. Sum of squares within the 3 groups. Notice how big the degrees of freedom are. There's only 3 groups, so that's 2 degrees of freedom between the groups. And minus 3 groups minus 1. Within the groups, there's many more. There's 8,418 the number of subjects in all 3 groups minus 3 in the 3 groups. Okay, and then the mean squares which is equal to degrees of freedom divided into the sum of squares, which gives us that number, and the so on and so forth, and the mean sum of squares between the groups, and then the F score, the F statistic for analysis of variance is the mean sum of squares between the groups divided by the mean sum of squares within the groups. That comes out to 276. And we remember that's a big number for team analysis of variance. The probability of being wrong, the significance or p-value, probability of being wrong if you reject your null hypothesis is less than 1/10 of 1%. Is less than 0.000, 0.001, right? So we would reject our null hypothesis that the 3 means are equal to one another. Now the question becomes, which of the 3 means are different from one another? So now we go back to our analyze, our compare means, our analysis of variance, and this time we do a post hoc test. And there's several options. I'll discuss the options a little bit more tomorrow. I'm going to use Bonferroni. Bonferroni, Tukey are very common choices here. I'm going to use Bonferroni. And this post hoc test will tell me, compare each of the 3 groups and individually, and tell me which of those is indeed, can I say that the means are different? In other words, reject the null hypothesis. I can say OK, and here is my output for the multiple comparisons for never smoked versus current smoker, never smoked versus former smoker, current smoker versus never smoked. Actually, that's the same as that, isn't it? Right, so we should get the same number. So what's the p-value? Well, the p-value for never smoked versus current smoker is 0.536. It's not less than 0.01, 0.05. Oh, I'm sorry. It's 0.061. Not quite enough to say with less than 5% chance of being wrong, that the mean for never smoked is not equal to the mean for current smoking. In other words, we can't reject that null hypothesis that they are equal. The means are equal. So that kind of made sense, doesn't it? Because it doesn't look like they were very different here in our box plot, the means or medians, right? Looks like they're pretty close to the same thing, the mean ages. Okay, well, how about comparing never smoked to former smokers? And how about comparing former smokers to never smoked and former smokers to current smokers? Well, in both cases, the p-value or significant is less than 0.05. So we can reject the null hypothesis that the mean age for former smokers equals the mean age for never smoked, and mean age for former smokers equals the mean age for current smokers. We can say with statistical certainty that former smokers are their average age is different than people that never smoked or current smokers. And indeed, we can actually see that difference here. Here, look at that. Look at the interquartile range where 50% of our values are. compared to smokers and people that never smoked and people that are current smokers. So that really is the older average age group. Okay, so we can do a lot of interesting stuff with this. There is another variable. I'm just about coming to the end here of our hour. There is another data set that I have in here, which is a simplified data set that what I've done is I've taken some of these variables. For instance, these variables in the beginning, we were really only interested in these 4 variables, which I moved up together. Well, do I really need all the rest of these? Well, you can actually highlight these other variables and you can actually clear them. You can remove them. And if you do it for all the other variables, that extraneous variables that you're not going to be working with, right, it kind of simplifies your use of the data set as you're working. Okay, well, I've actually done that for the data set that involves some of the variables we're interested in, where flu inoculation is of interest to us. So I'm going to go here. I'm going to say open data. I'm going to navigate to the same spot we were before. So this time I'm going to open up this other data set. Okay, simplified flu data. Okay, and here we go. And what we've done here is that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 variables that were of interest to us. Well, the main one we're interested in is, did you get a flu shot? 1 and 2, you can see that. Well, do we know which one 1 represents and which one 2 represents? Well, no, we don't. Look, I turn this on and off. If I go to variable view, you can see the values are not filled in. So we have to go to the code book and code this information. For instance, flu vaccine. Okay, did you get the flu vaccine? We would have to code in here. Have to code in here. I'm still having a problem with that. Nominal. I went into the wrong spot. I meant to go in, not missing. I meant to go into values. Okay, what does 1 mean? Does 1 mean that they got the flu shot or they didn't get the flu shot? Right, we'd have to look that up in the code book, wouldn't we? For the variable name flu vaccine shot to see what 1 represents and see what 2 represents. Okay, so I'll leave that up to you guys to play with. Even if it's the semester's over with, you have this data, you have access to this Blackboard course probably for many months to come. So I'll leave that up to you guys to play around with this stuff and go into it and understand and practice how you can create these descriptive statistics with this very useful program. Okay, like I said, it could be that for the exam, I may just give you this table and ask you to interpret. In other words, describe the study, give you the table, and ask you to interpret it, right? Or I might leave out this number, or leave out the degrees of freedom, and ask you to fill them in for me, because you know that this number divided by this number gives you this number, and this number divided by this number gives you this number. So if I leave these 2 numbers out, you should be able to figure it out, right? You should be able to figure out what these numbers are. Or if I give you just this column and this column, you should be able to figure out the remaining boxes that are here. Okay, the mean squares and the F value, because this is, if you have these 2, this is just this number divided by this number, and this is just this number divided by this number, and the F value is this number divided by this number. And if you need to, you could actually go to a table and look up what the critical value of F is for this sample size, right? And decide whether or not you can reject the null hypothesis rather than depend on this to tell you this. Or if that's there, you can just draw that conclusion from there. Okay, so I may give you, just the tables themselves, or maybe I'll give you some calculations that may be of some use as well. Okay, for instance, I'll talk about regression and correlation tomorrow night, and I might actually be able to give you a couple of formulas that a couple problems where you actually have to do a little bit of math as well. Okay, but I'll try not to make it too challenging. And like I said, over the next tonight's session, tomorrow night's session, and I also have ones for Saturday morning. And again, I'll post these. Between those 3 sessions, I think that you'll be pretty well prepared to do the exam. The way I'm going to set up the exam is that you have a set amount of time to do it. Maybe I'll make it, I'll set it at 3 hours. Should be way more than enough time to do it. And I'll give you 2 opportunities to submit it. And first time you submit it, we'll give you feedback on whether you have right answers or wrong answers, but not what the right answers are. So you can go back and take a look at it again and give it a second try again and see if you can do a bit better. Okay, so we're going a little bit longer now, so I'm going to stop at this point, and perhaps I'll see or speak to see some of you, and for those of you that can't make it in person, maybe you'll follow me online tomorrow afternoon at 4:15, or maybe you'll watch us after I post it instead. Okay, so good night, guys, and give this a try. See how you feel about this stuff, and use this as practice, even after we're done with the semester. For as long as your SPSS license works, or as long as you decide to keep it up, you can go back and play around with this stuff. And in fact, now that we have this virtual desktop thing, if you're willing to put up with some of the anomalies and a little bit of delay, you can actually do this on your own without having to spend more money on software. Okay, so good night, guys, and I'll talk to you again. Bye.